All right, thank you very much for having me, and good morning to those of you here in Phoenix, and good afternoon and good evening to everyone else around the world. So today, I'm going to change directions a little bit, and I'm going to be talking about odor detection or odor discrimination learning with dogs, and particularly the relevance of Pavlovian conditioning and its potential effects on discrimination learning and performance in dogs. So first, I'd like to start off with just a little bit of background. So as you might know, dogs can be trained to detect odors, right? It's been well known for many, many years now. You have police dogs, you have military working dogs, and you have another sort of growing area of using detection dogs for a variety of chemical stimuli. Even in terms of trying to track down wildlife, finding wildlife, cancer detection dogs are becoming popular. So there's a lot of research that's been going on in terms of sort of what I consider the what question. What can dogs be trained to detect? Can we train them to detect X? And typically, for the most part, in my opinion, and nearly all of the research that's shown this, the answer is always going to be yes. If you say, is there this chemical stimuli that we can train these dogs to detect? Typically, sometimes it takes a long time, but typically the outcome in terms of the research winds up being yes. So there's a lot of research that's tried to apply the use of the dog's nose to a variety of different stimuli. But one thing that I think there's been less research that has been exploring is particularly the parameters in terms of optimizing this detection training performance. Not necessarily just the performance, but also how long it takes to train them. These types of questions haven't really been addressed as much in the scientific literature. For example, in a lot of the scientific papers, the training part is sort of just a couple of line component in which we train the dogs. So there's a lot of other things that might be going on here, and I think there's quite a bit of work that could be done in terms of optimizing the way that we do training to optimize performance. So when I first started, one of the things I didn't sort of realize when I had my pet dog, and I was like, all right, I'm going to train you to detect something. And dogs, right, they're famous for their noses. So I thought, okay, I just got to point her nose to the odor I want her to find, and then we're done, right? I can call it a day, I can go home, I have an odor detection training dog. Well, it's not exactly that easy. If it is that easy, you can email me and tell me how you do it, because I would like to know that. But for the most part, for me, it has not been that easy. And for a lot of training dog programs, it can be very time consuming. It takes a lot of time to get the dogs to the levels that you want them to be. And by being time consuming, it's inherently expensive. However, the answer is not simply, I just have to train the dog, right? And then we're done. Now I can call it a day, I have a detection dog, right? It doesn't work that way. You have to have lots of maintenance training. You have to continue training after you have the initial detection training to maintain this performance. Why is that? Well, detection occurs in the presence of a lot of potential behavioral disruptors, right? There's a lot of situations, there's a lot of environmental noise that's going on when the dog is actually being asked to detect things in the real world. But also, there are other behavioral disruptors. Potentially, one important one would be extinction. So in a lot of real-world situations, right, if the dog were to alert to something, depending on exactly what that situation is, you may not necessarily reinforce that particular alert because, for example, it might be dangerous, depending on what you're trying to find. Or it could be you don't know whether it's a false alert or whether it's actually a true indication of something that they have found. So sometimes these things will be on extinction, but also actually finding stuff can be very rare. So there's a lot of different types of factors that might actually disrupt the performance of the dogs in the real world, which makes maintenance training sort of a necessity or a requirement to continue. But one of the things I've been generally interested in is, are there just these very simple, sort of cost-effective ways that we could improve performance? And one area, sort of looking at the literature is, well, perhaps we could use a very simple intervention. We could just give the dogs the odor that we want them to train, sort of like this idea of sort of pointing their nose in the right area. Just repeatedly expose them to that odor over and over and over again so that they become extremely familiar with that odorant. So that's the most familiar odorant that they have, essentially. And we do have some evidence in the scientific literature, not with dogs, with humans and with rodents, that repeated exposure can enhance detection thresholds or their sensitivity to an odorant, and also enhance discrimination performance or the spontaneous discrimination. And typically, a lot of times, you have a general phenomenon called perceptual learning, where simply being exposed to some particular stimulus over and over again facilitates discrimination performance. However, unfortunately, that's not always the case. It's not a very clear finding. And as you might imagine in science, it's not always so clear, cut, and dry. Sometimes you get perceptual learning. Sometimes you'll have no effect. You'll have no change whatsoever in detection sensitivity. Or we have another phenomenon, latent inhibition, in which, or adaptation or habituation, in which repeatedly being exposed to an odor is actually going to have negative effects. So it's pretty important to actually know whether this might actually have a positive effect, no effect, or a negative effect, because either on the benefits, it could be a very fast, quick conditioning treatment to enhance performance, or it could be doing the exact opposite and making performance worse. But in terms of exposure, that's not the only type of exposure you can have. So I'm going to frame another type of exposure, which we may not think of it purely as exposure, but Pavlovian conditioning. I really like Pavlovian conditioning, so I'm going to talk about it a little bit more. So on the graph here on the bottom, we're going left to right in terms of time. And in a Pavlovian conditioning paradigm, you can present some particular odorant, and then our typical setup is that we present an odor for 15 seconds. 10 seconds into that odor presentation, we simply present an unconditioned stimulus, or food in this case. And essentially what happens is that the odor presentation becomes associated with the food. And typically we'll have some sort of period of time in which the odor goes away, and that there's no odor, no food. And then when the odor comes back on, food comes back, right? So this is a form of Pavlovian conditioning that leads to an association between the odor and the food. And I'm going to consider it in terms of exposure. And it's nice because it doesn't necessarily require what we would think of in an operant paradigm, where you don't have to shape the dog to engage in any particular behavior. What you're correlating is the presentation of two stimuli under your control. So it's very easy. Pretty much anyone can implement this. All you need is a stopwatch and two stimuli, right? An odor and a piece of food. So one of the first studies that we looked at was, does these types of exposures have any potential effect on discrimination learning? So what we did is we took several groups of dogs, and in one group of dogs, we essentially brought them into the lab, and we gave them exposure to air, right? That seems kind of silly, but that was our control. So for 5 days, we just exposed them to clean air. Nothing particularly relevant happening. They were exposed to clean air. And then we trained them on a simple two-choice odor discrimination task. And this was their performance as we were going from session 1 to session 3. But a second group of dogs we brought into the lab, and instead of just exposing them to air, we exposed them to the target odor for 30 minutes a day of what we were going to train them on. And this is how they did. For the most part, really no different. It didn't seem to have any particular effect. But we had another group in which we would bring them into the lab. We didn't expose them for that 30-minute block of time, but rather just those very brief, few-second exposures that were correlated with the presentation of food. And this is the acquisition performance we saw for that. So we saw a significant improvement in terms of this Pavlovian conditioning group compared to our exposure group or our control group. So it did seem that this Pavlovian conditioning facilitates acquisition. It was nice because it was procedurally simple to implement. As I said, all you really need to do is have a correlation here between the presentation of your odor and the presentation of your food. So really, it required a research assistant with a stopwatch. Didn't require any shaping. We didn't have to train the dogs to sit. We didn't have to wait for the dog to sit. We were just presenting the two stimuli, and it was purely time-based. So we found that this Pavlovian conditioning can lead to faster learning. However, as you imagine, if I were to go back to that slide, if we were to keep training the dogs, right, this wasn't, the separation between our two groups wasn't going to stay forever. They were all going to go up to 100% eventually, right? So the other question is, well, maybe there might be other potential effects of this Pavlovian conditioning. Maybe not only does it make it faster, could it make sort of the learning stronger in a sense? And we actually have a scientific theory behind that, which is called behavioral momentum theory. And it predicts that the more sort of reinforcers that are presented associated with some particular stimulus, the stronger the responding to that stimulus will be. And there's a nice review in the Journal of Applied Behavior Analysis that you can take a look at if you'd like to learn more about that particular theory. So the aim of what I'm going to, of the data or the actual experiment I'm going to walk you through a little bit now, is to assess if could we use Pavlovian conditioning to lead to greater sort of resistance to disruption. And what I mean by that is a stronger performance. In other words, with all these disruptors in their environment, will they search more, longer, better, higher performance in the presence of these disruptors? So what we did here is that we took 12 dogs, and we trained them on 2 olfactory discriminations. I'm just going to call them odor pair A, odor pair B. So odor pair A is 2 odors, and they were trained to find 1 odor of that pair. Odor pair B is another 2 odors, and they were trained to find 1 odor from that pair. So we trained them on that, and this is just to prove that we trained them. So as I said, remember that, if we were to train, even with the Pavlovian conditioning, eventually they'd all sort of come up to 100%. Well, if you continue training, sort of that's what happens. So on odor pair A and odor pair B, they were both nearly at 100% accuracy on these 2 discriminations. So once they're already at this 100% accuracy, what we did is that we gave them Pavlovian conditioning in the Pavlovian group to one of the target odors. So the target odor for just, say, pair A. For pair B, we didn't touch it. We just left that as a control. And then we had another group is an unpaired exposure. So they got the same type of exposure, but here we didn't correlate the presentation of the odor with the food. It was actually explicitly uncorrelated, which I'll explain in a second. So we did that for 5 sessions to give them this Pavlovian conditioning or this unexposed exposure group after they had already learned about these different odors. And then to try and assess whether one was stronger or not, we tried to disrupt their performance. So the first way we did that is that these dogs were trained with food. So what we did is right before we went ahead and tested them in a typical session, we just decided to feed them right beforehand. We fed them either 50, 100, or 200% of their daily diet. So if your dog gets 1 cup of food, these dogs were either getting a half cup of food, 1 cup of food, or 2 cups of food right beforehand. So as you would imagine, this should probably have some disrupting effect if they were working for food. After we did that, we brought all the dogs back up to baseline. We removed this sort of pre-session feeding to try and bring them back up to that high 100% level and gave them either more Pavlovian conditioning to that same odor or this unpaired exposure. Then to throw them off their game again, we tried to disrupt them with odors. We had an odor distraction condition where we essentially buried food everywhere. So here they could find food just about everywhere, and we're going to see how many times would that sort of throw them off their game. We brought them back up to baseline again, and then the final disruptor was extinction, sort of the ultimate disruptor, if you will. So here, every time they made a correct response, we just didn't give them any food whatsoever. So as you'd imagine, they all sort of quit eventually. How did the Pavlovian conditioning look like? So this is the same sort of timeline that I showed before, but now we have a 15-second odor presentation. 10 seconds into that, we present food with a 5-minute intertrial interval, and we just repeat it again. The unpaired conditioning, we sort of have the exact same odor exposure here, but now the difference is that the food is right in between, so it's uncorrelated. For our detection training, we had a 2-choice discrimination. This is a procedure that we've previously published on, so for the details, you can see this particular paper. But for the most part, the odor was buried in 1 of 2 buckets of pine shaving. Since we had 2 odors, the target was buried in 1 bucket, and the non-target was buried in the other bucket. And we had 2 types of controls to make sure we didn't have any sort of experimenter cueing going on, to make sure that they were actually following the odor the entire time. So what did we really see? So on the y-axis, we have proportion of baseline. And what that is looking at is when you don't have any disruptor in place, right? That's sort of your baseline. And comparing that to when you have this disruptor in place. So a value of 1 here means that they're performing the exact same as they did when the disruptor was in place compared to baseline. Any value less than that means that their performance is going down compared to their baseline. So in the top graph here, we have Pavlovian conditioning versus the unexposed odor. So this is odor pair A versus that odor pair B, which we didn't really touch at all. And for the pre-feeding, for the most part, that didn't disrupt dogs all that much. Turns out we had some greedy little dogs. The odor distraction did disrupt them, but as you can see, we're starting to see separation here with the Pavlovian conditioning compared to the unexposed that continues through extinction. So to really test, how did this compare in terms to our unpaired conditioning, which we're getting the exact same sort of exposures, but now the food was coming in between the odor exposures instead of at the same time. And we didn't see these results at all. We actually saw slightly of an opposite effect, but this opposite effect was not really significantly different once you compare it to all of the cross conditions here between distraction and our extinction condition. So overall, our Pavlovian conditioning seemed to lead to greater resistance to disruption. The Pavlovian conditioning may enhance performance in this potentially disrupting environment. But we did not see this at all in terms of our comparison, our unpaired odor presentation group. So if you have any questions on that, feel free to email me. For more information, you can actually see where this information was published. It recently just came out in the Journal of Experimental Analysis of Behavior.